All right, so I'm going to go through this worksheet that you gave me. I'm going to try and get through as many pages as I can at once. I might only be able to get through the first page for this video, but I'm going to go through if there's anything in particular that you do not know, 100% you do not know, just let me know and I'll make sure I go through those. And if there's things that you do know, let me know, and that way I don't have to waste your or my time and I can just go ahead and skip those parts. But we will go through all this, and within this, when we get down here, there will start to be parts of the unit circle that we cover as well. But if this is the worksheet that Mr. Khan gave and asked for everyone to know, then this is what I figure would be best for us to go through. We probably won't get to the unit circle until actually like the second half of the year, if I remember correctly while I was teaching there. But if you have already been doing this and you know a lot of this, then just let me know which ones you do and do not know, and that way I can make sure that I don't go through anything that you do know. But I'm going to try and get through as much of this first page as I can, and then we'll move on from there. All right, so for this first one, number 1 and number 2, you have to know the difference between a bracket and a parentheses. All right, when we have a bracket, that means that we are including that number 0. So if we were to draw this answer on a number line, we would have 0 and we would have 5, and that means that it is a colored in circle at 0 and 5, and we are including this. All right, so when it's colored in, that means, or when it's a bracket, that means it is going to be a colored in circle, and it means that we're including, that means 0 and 5 are both the solution. When it's parentheses, it means that it is not colored in because it is not included. So here we're at a parentheses for 2, so it's an open circle. So that means 2 is not part of our answer. If we were to substitute 2 into the problem, it would not work. It would be equal to and maybe not less than or not greater than. But it would not be part of our solution set. And then from here, it's saying 2 and then saying 2 infinity. So that means that this is going to just extend as an arrow and will never end. We can never put a bracket with infinity because we can never actually reach infinity. Every number that you think is the largest number, we can always add one more to it. So we will always have to have a parentheses when we're dealing with our infinity and not a bracket or a closed circle because we cannot actually reach infinity. It then says find the endpoints, which is what we did here, endpoint, endpoint, and endpoint, and state whether the interval is bounded or unbounded. So in this case, it is bounded because it stops. It has a beginning and end. In this case, it is unbounded because it is going to infinity and is never going to stop. All right. Let me move on to the next set. I'm not going to go through every single question because when they repeat themselves, that way you can go through the second one. I'll go through at least like one of each type though. All right, so for the third problem, it says find, using the distributive property, write the expanded form. So all we're doing here is we are multiplying the 2 in. So we will distribute the 2 in. So it'll be 2 times x squared, which is 2x squared, and 2 times x, which is minus 2x. So that would be the expanded form. And then it says for number 4, it says use the distributive property to rewrite it as a factor in factor form. So this is number 3. So here, this is expanded form. This is factored form. It's where we have what times what. Well, actually, this isn't actually fully factored. But when we are trying to factor, we're trying to figure out what do we multiply to get to this. So we have 2x cubed plus 4x squared. So what 2 things or 3 things or 4 things could we have multiplied to get to this? So what we do is we look first for our GCF. We see, is there a greatest common factor? And each of these terms has can be divisible by 2. So that means we can factor out a 2. And when I factor out a 2 here, I can divide by 2 to figure out what I have left over. And if we also notice, they each have an x. However, this one has an x squared and this one has an x cubed. So when they have the same variable, you take the one with the smallest power. So that means our GCF is 2x squared. And what you can do to figure out what you have left over is you can just divide everything by that GCF. So 2 divided by 2 is 1. X cubed divided by x squared is x. 4 divided by 2 is 2. And the x squareds cancel. So we're left with 2x squared times x plus 2. So this is our factored form. All right. This is probably the most basic factor form that you will get. Usually you will have a trinomial, 3 terms that you'll have to factor out into multiple binomials or more. All right, I am going to skip 5 and 6. If you do not remember how to do 5 and 6, just let me know and I'll go through it. I'm also going to, I'll do 7. So oftentimes when we have very large numbers like this, which is 3,680,000,000,000. No, 3,680,000,000. We don't really want to keep the number like this, so it'd be very hard for us to leave our number in this form if we're trying to multiply, divide, add, whatever. So what we will do is we will write it in scientific notation. And that means we're going to write it by 10 to some power. And we need to rewrite this digit. And what we do is we will have one number, a decimal point, and then we will have the rest of our digits. This first number has to be any number that is greater than or equal to 1 and less than or equal to 9, but it can only be integers. So it means it can only be whole numbers. So you can't have like 2.5 or you can't have 3.4. But this needs to be some number greater than 0, so it can't be 0. We want to have some digit there other than 0, but it also can't have 2 digits. That's why it can't be 10. We only want 1 digit there. So for this, what we do is we look and we find the easiest way of doing this is we find our decimal, and our decimal place is out here. Our decimal point is out here. So what we do then is we count how many spaces do I need to move this to get to where I have a 1 digit by itself. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can rewrite this in as 3 point, and then I have my 6, 8 remaining, and then I times 10 by however many decimal places I need to move, which was 9. So these two numbers are equivalent to each other, but this is written in scientific form, and this one is not. But this one is now easier for us to multiply or divide. It allows for us to do more calculations than we could have here. Because if you try typing 3,680,000,000 into your calculator and multiplying it by 4, the calculator may give you a number that's too large, which then it will rewrite it in scientific notation for you. So it just allows for us to do more calculations with large, or in this case, very small numbers, right? When we move it to the left, or what you can think of is when we make this overall number smaller, which is what we did, we made it smaller to get to here, then we need to make our tens, when we multiply it by 10, we need to make that larger, we need to offset it. So in this case, we make it smaller. 3.68 is definitely smaller than 3,680,000,000. So that means our tens need to be larger. In this case, when we move our decimal place to the right, we would then change it to 7 times 10. And 7 is definitely larger than 0.000007. So that means when we make this number larger, this number needs to get smaller. So it would then be multiplied by 10 to the negative however many decimal places you moved. All right, so that's one of the ways I think it's easier to remember, rather than if you move left, or if we count left with your decimal, then it gets positive. If you move right, it gets negative. I just think about, am I making this first number smaller or larger? If I make it smaller, then my tens has to be larger. If I made it larger, like we did here, then our tens has to be smaller. All right, they will always offset each other. All right, so for number 9, it says, I'll do number 10 since it's negative, but it says write each in decimal form. So we have 9.1094 times 10 to the negative 28. So then if I'm trying to write this in decimal form, I know that since this was negative, that means I had to have made this number larger, larger. So that means I need to make this number smaller if I want to get rid of these 10s. So that means I'm going to move this 28 spaces to the left. So I'm not going to actually write this out, but it'll be 0.0 27 times and then 91094. So we would then move this 1 and then we would move it 27 more times. So we would have 27 zeros. And then we would have 91094. So you can either, all right, if you want to remember that when it's negative, that means we move it to the left. If it's positive, we move it to the right. Or like I was saying before, if we were to make this or rewrite this and we made this into a negative number, that means we made it small. That means this got smaller, which means this we made larger. So we need to make this one smaller to put it back in its normal position. Which then means if we want to make it smaller, we need to move this to the left because we need to make it into a decimal, not into a whole number. If we start moving this to the right, then this number will be getting larger because it will go from 9 to 9 billion. All right. I'm going to skip 11 because it's kind of applying these two, 7, 8, and 9 and 10. You would first just write it in scientific notation, and then you'd go on. I'm going to skip 12 because you can just type that into your calculator and see for yourself. But if you need help with those, please just let me know. All right, so for these, it says find a distance. I'm going to do 14. And I'm going to show you 2 ways that you can do 14. So the first way we can do this is we can plot these as a point. Oops, let me just try and make this a little bit straighter. So we can plot these 2 points in our coordinate plane. We did this in geometry, so I know that you did this before. So we have -4, 3 right here. And then we have 1, 2, 3, 4, 5, -1 here. So we have -4, 3, and we have 5, -1. So there's 2 ways you can do this. One, when we have 2 points, so let's just imagine that was a straight line. Okay, let me just redraw this. When we have 2 points, we can draw a line connecting them, and if we draw these on the coordinate plane, we can then always draw a right triangle. I can draw a horizontal line that will match up perfectly with where this point is, and then I can draw a vertical line. And then these 2 horizontal and vertical lines will always connect to make a right angle. And then this will give me a point. Because this is equal to the same x value, this will be -4 because we didn't move anywhere left or right. We just went vertically straight down. And then this one, since it's horizontal, it's equal to the same y value because we didn't move up or down at all. So this will give us a point of -4, -1. And then we can go ahead and say, well, we have a right triangle, so we can use Pythagorean Theorem. This, we didn't move anywhere with our x, but we went down 4 spaces. Here, we didn't move anywhere with our y, but we moved from -4 to 5, so we moved 9 spaces. So we can then say, well, 4 squared plus 9 squared is equal to our hypotenuse squared. So 16 plus 36 is equal to our 8 squared. We can then say our hypotenuse squared is equal to 52. We can take the square root, depending on how the question wants. It does not say whether or not they want in decimal or in radical, so I'm just going to leave this in radical. So we can then say that our h is equal to 52 can be divided by 4, and 4 goes into that 13 times. I can take the square root of 4, that's 2, so that means this can come out. And I cannot take the square root of 13, and there's nothing else I can divide into it, so this can be rewritten as 2 root 13. So that will then be our distance. And that's rewriting it as a right triangle. You can always do that when you're given 2 points. However, that could take you a little bit of time. And do you want to waste time? No. So what there is there's a formula that you can follow, right? And the formula is essentially what we're doing there is it's going to embed the Pythagorean theorem into it. But our distance is equal to the square root of our x2 minus our x1 squared, which is essentially how we got our one of our side lengths of our right triangle, plus y squared plus y2 minus y1 squared. So this is essentially our Pythagorean theorem and then taking the square root to solve. And then we can just go ahead. When you do this though, what is important is when you denote that one of these points is x1 and y1, then you just need to be consistent. So if we say this is x1 and this is y1, and then that means this has to be x2 and this has to be y2. Then we just plug it in. It's a square root of 5 minus -4 squared plus -1 minus 3 squared. So it becomes a square root. 5 minus negative is positive, so it becomes the square root 9 squared plus -4 squared. So then from here we will have the square root of 81 plus 16 square root then of 97. So now that I'm doing this, I probably did the other one wrong. I'm sorry. I went through it quickly. You might notice, I guess when I did my x values, I didn't do it 100% correctly. I'm trying to go through this quickly because there is a lot of questions to go through. So let me just go through this real quick again. See, we would have been at -4, 3, and 5, -1. Yeah, so here, this one was correct that this was 4. But this one should have been 9. I don't know what I did in my calculations. I think I might have did 6 or something. I'm not really exactly sure how I got what I got. But it should have been 4 squared plus 9 squared, which then would have been 16 plus 81, which would be the exact same thing that we had here. All right, so I apologize for that. Hopefully that doesn't confuse you. If it does, just let me know and I can go through it in more detail. I'll try and go through these a little bit slower so I don't make any more mistakes like that. But not only does it ask you to find a distance, which this is the distance formula, it asks you to go ahead and also find the midpoint. And we did this in geometry as well. So I know that you know how to do this, or at least you did know how to do it. Maybe you don't remember anymore. But it is the average of your x's, so x1 plus x2. And when we're finding the average, we divide by however many we have. And the average of our y's, so y1 plus y2. So same as thing is be consistent. So if we said that this is x1 and y1, and this has to be x2 and y2, so it'll be -4 plus 5 divided by 2, and it will be 3 plus -1 divided by 2, and we put it in parentheses because it's an ordered pair. So this will then give me 1/2, and this will be 3 plus -1 is 2, 2 divided by 2 is 1, so this will be our midpoint. All right, so those are the two formulas that you would need to know for that. I'm not sure if Mr. Raybert will give you formula sheets or not, or if he expects you to memorize them, but you have used these before, so hopefully it is something that you remember how to do. I only have time for a few more problems, so I'm going to try to go ahead and go through this a little bit. All right, I'm not going to go through 17 and 18 right now. I'll go through that in a different video because this is something that I don't think you would have done yet. So this is something that's brand new. So I need to go through that a little bit more in detail. I mean, I know I'm going through these kind of quickly and not that much detail, but because you have learned all this before. So maybe it's just refreshing your memory. So 17 to 20 you would have not have learned before. 21, find the length of the side. So it's giving you the point. So if you just use your distance formula for that. Yeah, so I'm just going to go through, I'll stop at this one here. All right, show that the figure determined by the points is the indicated type. And I'll tell you what you can do for 16, but what you need to do first is we need to plot these points. So I'm just going to approximate where these points are. I'm not going to go ahead and plot these exactly. We have -2, 1, so that will be somewhere around here. We have 3 and 11, so 3 and 11 will be somewhere here. So 7 is beyond 3. 9 is below here, so 7 and 9 will be somewhere around here. All right, then I'm going to go ahead, I'm going to draw these, and what they're saying is, so then we have 3, 11, we have 7, 9, and we have -2, 1. All right, after you sketch this, there's really only one angle here that can be your right angle. And if this was a right triangle, this would be our right angle. So what we need to do now is we need to find the distance of all of these sides. So this question can take some time. So I'm going to go ahead and find the distance between these 2 points, this one here. So it will be then the square root of 3 minus 7 squared plus 11 minus 9 squared. So this will then give me negative 4 squared plus 2 squared. So it'll be 16 plus 4. So it'll be the square root of 20. I'm just going to leave these in radical form. I'm not going to simplify them because this really doesn't matter how long it is. We want to know just, is it a right triangle? So writing it in decimal, writing it in simplified radical really doesn't do anything for us right now because that's not what we're trying to solve. Right? Then I'm going to solve for this side. So once again, it'll be the square root. So it'll be 3 minus negative 2 squared plus 11 minus 1 squared. So then here we will get 5. So it'll be 5 squared plus 10 squared. So it'll be 25 plus 100. So it'll be the square root of 125. So that means this distance is the square root of 125. All right, let me just erase this. And then the last one. The last one that we will have to do then is we will need to find the distance between these two. So then we go down and we will then have the square root of 7 minus negative 2 squared plus 9 minus 1 squared. So this will then give me the square root. This will be plus. This will be plus. So we then the square root of 9 squared plus 8 squared. So then it will be the square root of 81 plus 64, which will then give me 145. So here's my 3 side lengths. Now, even if I wasn't sure which one would have to be my right angle when I drew this, maybe I'm not sure, maybe I don't trust myself. I know that if this were a right triangle, which is what they're trying to say it is, then this would have to be my hypotenuse, something we learned before because it is the largest side of all of them. So then that means the angle across from that would have to be our right angle if it is one. And if this is a right triangle, then that means it satisfies our Pythagorean theorem. A squared plus b squared is equal to c squared. So what we do now is we just substitute them in. And it doesn't matter which one you make, a squared and b squared, but 125 squared plus the square root of 20 squared. Does this equal the square root of 145 squared? If it does, then it's a right triangle. If it doesn't, then it's not. So it would be 125 plus 20. Does this equal to 145? And yes, it does. So since they equal to each other, we know that this is a right triangle. So even if you weren't sure by after you drew it which one would be the right angle, once you find the distance of all of them, you know that this one had to be our hypotenuse if it was a right triangle because it is our largest side. And then that then tells us that the right angle would have to be across from that, and it tells us how we plug into our equation. To solve for number 16, you're going to do the exact same thing that I just did here, but the difference is, one, you have a little bit difficult of a point, so you may take a little bit more work with that. Just use your calculator. But also, once you find the distance between them, you find all these, then they all just have to be equal. And if they're not equal, then they're not equilateral triangle. If they are equal, then they are. So it's a little bit different. I think it's a little bit easier in the sense that you don't have to do this last step, but this one could be a little bit more challenging because you do have a radical built into your point. But this is the answer for number 15. And number 16, you're essentially doing the same thing, but you're just going to compare them at the end. I'm sorry that this video is not as long as I thought it was going to be in the beginning, but I will go through the rest of these as quickly as I can. Within probably on Friday night and Saturday, I'll go through a bunch for you.